Okay, so we are going to move on then to a panel session on the Heilmeier questions. Just by way of hands, who here knows the Heilmeier questions? Excellent. Oh, this is great. Not too many people. So come on and join me. Okay, so we got Daniel, Tiffany, and Chris. And I'm going to sit down because it's really awkward to be standing while you guys are all sitting. That's okay. We're going to talk through the Heilmeier questions. And the reason the Heilmeier questions are important is that it's the structure and the language that DARPA uses to communicate new ideas. George Heilmeier was a former director of the agency, and he came up with this set of questions. They have turned and changed slightly over time. Depending on how you count, there's 7 or 8 Heilmeier questions. We are mainly going to focus today on the first 4. And these are the ones really at this point that are the most important as you're trying to communicate a new idea, as you're trying to get the attention and interest of a DARPA program manager. Maybe before we sort of jump right into the questions, let's just quickly introduce ourselves. Maybe you guys can give a little background on what office you're from. Chris, we'll start with you on the end.
Morning.
Daniel, sorry.
Morning. I'm Dan Ridge. I'm from the Microsystems Technology Office. I've been at DARPA as a PM for 3 years.
Good morning. My name is Tiffany Prest. I'm in the Biological Technologies Office, BTO, also known as the Best Tech Office. And I have been a program manager since 22, so also 3 years.
Chris Kent, program manager in TTO, Tactical Technology Office, also the, I guess, antithesis of DSO, I guess.
Jeez.
Yeah, opposite end of the spectrum. And I'll be 3 years in December.
All right. So here's all the questions. I think these are in your book, so you don't need to take notes. Let's just step through them one at a time here and spend have a little fun discussion about what you've seen in your experience that is the good, the bad, and the ugly. And I know there's a lot to talk about here. For what makes a good response to a question. So let's start with question number 1, which is, what are you trying to do? This sounds like a pretty simple question, but it's really tricky to get this one right. I don't think it's the hardest of the 4. We'll get to that. But there's a lot of missteps that people can take here. So maybe Dan, let's start with you. When you're thinking about your H1, let's start positive. What makes a great H1 when you're reading a white paper?
So the first thing I'll say about this is I'll flip it around and say that the no jargon is as important as what you're trying to do. The jargon is so strong with us that we call this, well, that's your H1, right? We use jargon itself to frame this. And so what I like in an H1 is to see that you are focused on an actual problem that you're going to solve, not the technological way you're going to get after it, that you can decouple those. That's the first thing I'm looking for. The second is related, which is to see that you are not trying to do a particular piece of technical work and you've tried to back into a problem that somebody might value a solution to as the reason to justify the work. We're looking for things that the work proceeds from the problem rather than inventing a problem to fit the work.
So I love all of that. Agree. Also, having been a former teacher, realize that sometimes it's really easy just to fill the space. Say what you got to say, and get off the stage. Pithy, pithy, pithy. If you can't drill it down into a single sentence, then maybe you need to think about it a little bit more. I'm okay with using the semicolon, it's fine. But I'm saying, like, being pithy is really hard, and this one you will always come back to as you write the rest of them. You will always come back to the H1 jargon and refine and refine and refine and refine, and that's fine. And as you refine, it will get smaller and smaller and smaller and pithier. And so as a program manager, I don't have a whole lot of time. Y'all don't have a whole lot of time. So say what you got to say, get off the stage.
Yeah. I don't really have anything to add. Those were ones, just the focus on concise, easily read, and also don't think that the first version of it that you make is going to be the final version of it. You hit on that. Like you change your H1 quite a lot as you go through your thinking process. I like to refer to the Heilmeiers as a process, not a bunch of questions. And they really help you think through and structure your programs. And I don't know how many times I've gone through them for each of the programs I've started, or the one program I've started. They probably 50. And it really does change it. And be open to that you can change what you're trying to do with your technology. But one of the ones that Dan hit on that I always see a lot of is I have a hammer. I can hit that screw in. No, please tell me what problem you're solving first, and then go from there. Okay.
Through the lens of the Department of Defense.
What?
Through the lens of the Department of.
Yes. Yeah. Absolutely. I mean, so the D in DARPA still stands for defense, at least for now. So we'll see how we go.
The only thing I'll have to add to that is be quantitative. You know, DARPA is a metrics-driven organization, and those who've worked on a DARPA program know that. We live and die by the numbers. And so instead of just saying, you know, I'm trying, let me try to think of an example. Like if you're thinking about teleportation, right? You know, I'm trying to teleport an object from A to B. Well, be a little bit more specific. I'm trying to teleport an object with a mass and size of X to B in, you know, Z amount of time, right? That's like get quantitative, even if it's rough numbers at this point. We like to see the numbers. We like to see how you're thinking quantitatively. A lot of H1s are just fluff. This is very qualitative, generic statements. That's a no-no. All right, the second one is trying to really set the state of the art, right? How is it done today? And what are the limits? And this ties back to what you're trying to do. Obviously, these all tie together. Right, to Chris's point, this is more of a continuum than discrete series of questions. So how is it done today? What are the limits of current practice? Dan, let's start again with you. Just some thoughts here.
The lead that's buried in there is the it, right? And this is an example of an H2 that proceeds directly from the H1. And your H1 is the it, right? And so I think one of the weaknesses that we see is an H2 that says, well, in fact, what I'm doing is so revolutionary, it's never been done before, and my improvement over the state of the art is going to be infinity. And that's actually a sign that you have the wrong H1. If you can't identify an improvement over the state of the art that you're going to make that's a factor of 10 or 100 or whatever it is, it means you don't have the right H1. And that's why the quantity is so important, as Andrew said, but also why identifying the figure of merit is important. And that's actually a lot of the work here, is tying it to the H1 and identifying what the figure of merit is.
So I like to think about this one as the one, like, did you do your homework? Like, you know, we all have like limited time, right? And y'all are experts in your field and you have this great idea. And the question is, did you do your homework? Did you do your homework about like the department? Did you do your homework about what the military needs? Did you do your homework about the science? Did you do your homework? And then following up on that, I want to learn something new. Like, I want to learn something new, and I want to be surprised by the H2. Generally, I'm probably not going to be, and that's totally fine. But like, make sure that you're read up on the literature. Like, make sure, if you're, again, from the biological perspective, like, make sure that you're tracking what the newest and greatest things are, and make sure you're referencing, like, you know, current papers. Sometimes the 2004 paper is seminal and like pivotal, and you need to reference that too. But like, also make sure you pull in, like, you know, the 2025 papers as well. Did you do your homework?
I work in ships, so 2004 is probably pretty current, but nonetheless, I really, Tiffany said about I want to be surprised there. It also is about your H1. So a lot of the time people are like, well, I want to do this in a whole new way, therefore H2 is satisfied, but the it is still whatever the operational effect, the H1. So you need to show that your solution is, or actually you shouldn't show your solution, but show what the current today's practice for that problem is. So this is more about doing your homework, making sure that you've surveyed the field, understand the challenges that are there and how you're overcoming them. It comes later in the Heilmeyers, but this is the limit of current practice is really important to capture, especially in TTO programs. We have tend to do a lot of platforms, and that is always a challenge because we're trying to insert a platform here in a gap, and it doesn't necessarily, there is no limit of today. So these ones are, particularly for my office, can be a challenging question to answer at times.
So I just want to add one thing that is also really helpful. Sometimes this one needs to be decoupled. So sometimes you need to say, how is it done today in the military? Which, there's a significant gap there. Yeah. And then also, how is it done today in, the burgeoning research field, right? So it's okay to decouple it. And sometimes it'll make it cleaner too.
Yeah, that's a great point. Like I'll use AI, just a quick example on that is a lot of the challenges in the military, we can't access back to the cloud. We have a lot of comms issues. And therefore, a lot of stuff that's done in industry today is super easy and is, the easy button. We just can't do. So you have to think about it from our use case.
And I would add to that, especially for people who are bringing ideas to our DARPA packaged in Heilmeier format, that if you come to us and say, I have now perfected the ability to do X, you represent the limit of the art, right? Yeah. So we can't invest in that. We now need to overachieve what you've done by an additional factor of 10 or 100 for it to be worth DARPA's time. And so that's why you often get frustrated by a cold response when you're like, but I perfected strawberry chocolate milk at room temperature superconductors. You're like, well, it's perfected then, like done.
Yeah, that's a really good point that hasn't been made yet. I mean, the way I like to think about it too is DARPA isn't buying what you're selling. And I'm a material scientist, and so I've seen this like through a material data sheet. I get this all the time. A small company or a professor has invented a new material. Here's all the properties. What do you think? Is this a DARPA program? No, we've already done it. It's great. I love it. I'll try to make connections for you, right, to other government labs that could maybe use your material, test it in an application, but that's not a DARPA project. So we see that a lot.
Yeah, or other offices as well. I mean, if it can lead to a capability that we need, then have at. But it that happens a lot. I appreciate when it does. So yeah.
Okay. You know what else works well here? I'm surprised no one said it. Is a good white space chart.
Stop it.
Do you not like white space charts?
No.
I love them.
Seriously?
I really don't like them. But
Dan, do you like white space charts?
He does make a good point.
It's a bit jargony, I know. Maybe we could tell the audience what a white space chart is.
Well, I'll get into that. Okay.
Oh.
So, all right, classic white space chart for aircraft speed and range, right? So plot the speed and the range of every aircraft ever produced, right? And there'll be a trade-off. And there'll be a big old white space in the upper right-hand corner. That's where you're trying to get to. Those kind of messages are very high level. That's probably why Tiffany doesn't like them. But they're really useful to communicate what your project's trying to do.
I don't like them because biology is squishy and oftentimes not quantifiable like that.
All right, we have different backgrounds.
So,
well, consider a white space chart perhaps for H2.
What I do like about the white space chart is it forces you to get down to what the figure of merit is, because you have an axis that's speed and you have an axis that's payload, and neither of those is what you're trying to achieve in the program. It's some composite metric, and being able to plot it and show where there are no answers is how you get what the figure of merit is.
Yeah. I would say best white space parts, the third dimension is obvious, but also insightful as far as like figuring out how big the leap you are going to make in.
Well, let's just put it in non-metric multidimensional space then.
Oh. Sounds good.
All right.
Tesseracts.
We should have talked about white space charts before. All right, let's move on to what, in my opinion, this is the hardest question to answer. This is the one where I even get myself tripped up on this one. Is what is new in your approach, and why do you think you'll be successful? Okay. The problem I see here is lack of specifics typically. So what is really new? Tell me something I don't know. What I see a lot is, oh, we're going to sprinkle machine learning on this problem and everything's going to work out fine. Don't worry. No, right? This is a very challenging question to answer. So, Chris, let's go the other direction here so that you're not the last one. Let's start with you on some things you've noticed about H3. What makes a good one? What problems have you seen?
Yeah, so again, I think this is the hardest question, usually. Make sure there is true insight in there, not just an application of your widget. It has to truly show that there is something new, but that you need to make it better. So getting back to the question, what Andy said earlier, if it's solved, DARPA's not interested. So it's, hey, we've started down this path. We think that we can get X% better with their H1, and then that gives you this capability, right? Or orders of magnitude, pick your metric of the day. That is truly getting that across concisely. It can be challenging, but the structure it brings to the problem is important. So I'll leave it there.
This one is my favorite one. I think of science as like art, this is where you get to paint the picture. This is where you get to really sell it, right? And this is where you get to also talk about the risk. There's more times than the later Heilmeier questions you can talk about risk, but here this is where you really show us where the reason why DARPA needs to invest and why the department needs to invest and why this idea is so crazy. And honestly, for me, when I approach this, which by the way, we always have to, you give us HQs, we have to also defend HQs upstairs to the director and to our office directors and everything. So the better you write these, the better you help us being able to justify trying to get you money. But this one is, I like taking, so DARPA, we bring disparate areas of science together, right? And this one is the one where I think oh, there's this cool physics idea. I wonder if we could apply that to a cell. Or oh, there's this really interesting way that in pure math you can do this thing. I wonder if we could do that in machine learning. This is where you can cross fields and be this isn't my area of expertise. I've never done biology before, but I'm really good at, I don't know, building a airplane. Maybe we can build an airplane out of microbes. I don't know. But so this is where you can kind of show your forward thinking and be excited.
But show how that's possible too, though. You need to, H3 has to have.
Well, yeah, absolutely. Yeah. I mean, back it up with literature and stuff.
Yeah. Literature and stuff. Yeah. So I would say that to talk about H3, we have to share with you what one of the most frustrating things about being a DARPA PM is, which is that we have no lab benches in our building. We have no drafting tables for our naval architects. We have no scientific workstations. And that's kind of intentional. We're not winning if we wind up trying to do the job and achieve the program ourselves. Our job is to get America to answer these problems for us, right? And so what that means for H3 is if you have a problem in H1 that you're going to solve, and exactly one way that it could be achieved, and that's your insight, then you don't have an H3. The H3 needs to be an existence proof that convinces us that a solution does exist. And then our job is to come to you and say, this is the problem we're trying to solve. This is why we think it's possible at all. But we need to be not prescriptive about the only ways that it could succeed. And so that's a challenge in crafting this, because if you have an H1 and an H3, you have a pitch for a company, not for a DARPA program to go do. And I would say that the other thing about H3 that is important to me is related to what Tiffany just said, which is this multidisciplinary, but it's to recognize that a previously unsolved problem in another area that has recently been solved is isomorphic to your problem, right? And it's those things, that it's this interaction at the seams. And so that's why it's important that we're all in the same building together, because we are able to fold what has recently been done in Tiffany's portfolio and say, she's solving the same problem I have, and I never thought of it that way.
Example, fungal mycelial networks underground are actually just electrical currents and circuits.
And that's Star Trek Discovery right there. It's the whole-
Okay, and last but not least, we'll just talk about the fourth question here, which is who cares? And I'll tell you that this is one of those questions that I think is easy to just fluff, but it is getting more attention lately at DARPA because it speaks to the transition of your technology and what capability or impact it will bring to the warfighter. And so this one I think is more important today than it has been in the recent past. And so I would encourage you to put more effort and thought around this. Now, the tricky part here is that you all in the audience don't have the same network that we have, and you can't see all the things that we see. So we're not expecting you to know exactly how your technology will impact some tactical technology. But give it your best shot, right? What's your vision statement for how, if you are fully successful, it will change the world, right? And again, here, being quantitative in all these is helpful. This is another one where I think it helps to be as quantitative as possible. Otherwise, you tend to just give us fluff, and that's not very helpful. So, Tiffany, let's start in the middle this time with your thoughts on H4.
Yeah, so I think this one is really, like you said, very pivotal. And this one I think sometimes is sometimes if you start with your H1, I oftentimes will go to the H4. So what's the problem and what do you want to do? And then who cares? And this one will help you frame it through the lens of the military. Why does the military need to care about this? And maybe even perhaps who in the military may care about this. But from the perspective of DARPA, it doesn't, military, and you'll see the breakout for the BTO, right? The military is so much larger than just the warfighter, right? National security is part of our purview, right? Making sure that people have food to eat, that's part of our purview. So there are many ways that you can still think about this through the lens of the greater United States. But I think this one is really great for helping you frame sort of why DARPA should care.
I was just going to add, I like the fact I was to point out, I actually usually, at least for me, I tend to change the H4s because I know more about but give it your best shot. What I really like is when an H4 and an H1 work well together and show that you've thought through the problem. So it doesn't have to be perfect. The PMs will almost certainly change your H4 or the office directors or whatever as you go through the process. But there is a real if there's a good synergy between those four, it helps you or us as PMs understand where you're approaching the problem from very clearly. So I think that's really important.
I think that's exactly right. I think that the H4 is really a quality check on your H1 in many ways, right? And that you need to work on your H1 if an H4 doesn't immediately suggest itself. But I'd also say that the problem of finding one person who cares deeply in your H4 is very different than coming up with the spanning set of everybody who might care. Mm-hmm. And it's much harder. And it's much less interesting to say all of these people might possibly care, because in the sweep of time, the people who ultimately care the most and save the most lives and add the most to the American GDP are probably not the H4 that you identified at the time you created the program. But if you were successful, you found somebody who could carry it until the match finishes lighting, right? And so that's really who you're looking for. Who can carry this past DARPA's involvement to the point that it is completely world-changing? Love it.
Okay, so now when you hear a program manager say, hey, what's your H1 or what's your H3? Now you'll know what we're talking about. That's a little bit of jargon and inside baseball. Now, we've made it sound like a pretty tall order, and it is to get it right. But I think, as Chris said, it's an iterative process. So take a stab at it, right? And reach out to a program manager. We'll help you make it better. We'll help you craft it into what we would need to see in order to sell a program internal to DARPA. So it's a back and forth. It's sort of a way to have a conversation, a structured conversation around your ideas. Always comes back to the idea. Now, I think Tiffany's going to lead a session now about how to engage a program manager and perhaps have that conversation about your Heilmeier.
I am.
So I'm going to get off the stage. Thank you for your attention.
I'll switch.
I think that's still here.